I'm Joeri. I work for the city government of Antwerp, for the Polis, as a platform architect. And because they have an extensive collection of microservices, like like 300 microservices, I've come into contact with this concept called service mesh and sidecar proxies. And I know that's a lot of buzzwords for you. Some of you may be thinking, you're making this up on the spot, that's not a real thing, you got it out of a random word generator, but I swear to you, it's a real thing. I want to explain to you what it's about. So let's say you have a microservice network, like the situation on the left. I drew 3 boxes, but imagine 30 or 300, like something that's supposed to be a big scale. You're going to naturally roll into a pattern where you have an API gateway sitting in front of that. That API gateway is going to provide a unified API, combining all your microservices together to a client, and that is going to handle a bunch of cross-cutting concerns for your microservices, like authentication, authorization, load balancing, service discovery, encryption, routing, that kind of stuff. You can handle that in your microservices, but it's easy to pull that up to the API gateway because it's shared that way. Now, if you do that, that's great for north-south, between client and service. But what you do with your east-west traffic between your microservices, if you send it over the API gateway, you can use all that cross-cutting functionality, but you add latency because you have a network hop and another network hop is actually quite slow. And if you have these daisy chains of multiple service calls, that starts adding up. Also, because you're sending all your traffic over the single API gateway, that can cause a lot of issues trying to scale that, especially as you keep adding services and interaction. So that's where service mesh enters into the picture. Basic idea is the situation on the right. You see that next to every microservice, there is now a sidecar proxy. The sidecar proxy is sitting on the same machine. In Kubernetes, it would be hosted in the same pods, but a different container. So it's sitting on the same machine. And that means the latency of reaching that is a lot smaller than reaching up to the API gateway. But it's still handling all those cross-cutting concerns, like routing and authentication and authorization and all of that stuff. So that makes it that your performance improves, but you still don't have to put that in the code of the microservices. You can still have an API gateway in front of it, but you can even figure out architectures where you don't have that anymore. Now, the really powerful thing is that these sidecar proxies, they plug into a control plane. In the control plane, it gives you a central place to do policy updates. You can update your routing, you can update your authentication, but it also gathers telemetry. So you get this status dashboard of all your microservices. You can do end-to-end request tracing, all of that fancy stuff, and you can do it in a standardized way across this huge landscape of microservices, probably all built in different things. So that's the basic idea of service mesh. I mean, there's a lot more to say about it. If you're really interested in the subject, I would say check out Istio, I-S-T-I-O. They're one of the major service mesh platforms. They have super, extremely detailed documentation, very nice. But that's basically all I can talk to you about today. So that's it, service mesh. Thank you.